Hello class. In this video we are going to discuss the dangers in using voltage of the mains as well as the effects of this danger on the human body, on the different appliances, and what are the means that we use to protect from this danger. Okay, let's start first stating the basic two dangers in using the voltage of the mains. So the first danger is electrocution accidents, which is when we misconduct or misuse electricity in some way. We touch an outlet or we touch an appliance in a not in a very correct way. That may cause electrocution. Okay, and the other danger is fire. So some appliance may catch fire because of a current overload or something called a short circuit. I'm going to explain now what I said in details. So first, we are going to start with the effects on the human body. First, the human body is a conductor, and when the skin is wet, the conductivity increases, making the danger more significant. So as we said in the previous video, the human body is made up of 70% water. And we know that water, because it contains electrolytes, it's a conductor. Okay, so our body is a conductor and it has a specific conductivity, which is the amount, let's say, of electricity it can conduct. But when the skin is wet, when our skin is wet, when it's moist, the conductivity of our body increases. That's why we say that we shouldn't touch, we shouldn't work with electric appliances having wet hands, because that might increase the risk of electrocution. Also, the danger of electricity on human body is presented more in the current rather than the voltage. What's really dangerous about electricity is the current. Okay, it's the current and not the voltage itself, because the current passes through the body. Okay, so the two dangers are in this: having longer duration, having the current pass through your body in a longer time, that increases the risk of death. And if the path of the current includes essential body parts or body organs, so let's say if the current passes through your brain, your heart, this may show a significant risk of death. Okay, that's why we have to be super careful when dealing with electricity. Now I'm going to show you this table. It shows here the duration the human body can withstand before death. So if we have a current of 10 milliampere, the body can withstand for 30 seconds before it reaches the threshold of death. If the current was of 100 milliamperes, then it can stand for 3 seconds. I guess this is of 1 ampere. Let me fix it. 1 ampere, the body can withstand only for 0.01 seconds. So the duration is very significant. The longer the current was passing through our body, the more our body is prone to risk. Okay? Now we saw that the effects of electricity on the human body is it's a major effect. It poses a big danger. How can we protect ourselves from this danger? There are many ways to protect. We're going to see now in the second part of this video how we protect ourselves from this danger. Okay, first let us, before talking about how we can protect, let us talk about the second danger. The first was electrocution, the second is fire. So let me show you exactly how fire occurs in electric circuits. Let's say we have this lamp here, which is 7 volts. So assume we have a lamp. The indication on the lamp states 7 volts. So this lamp can withstand 7 volt, or it acts normally under 7 volts. And we connect this lamp to a 110 volt voltage source. So 110 volt source. Okay, what will happen to the lamp? What will happen to the lamp is that it's gonna burn out, right? So the lamp will burn out. The circuit overload causes the lamp to burn out, and that may cause a fire, okay? The second reason for a fire is a short circuit. Let us explain now what is a short circuit exactly. Let us first take this circuit here. So this circuit here, we have a dry cell of 5 volts, and it's connected to this lamp of 5 volts. This lamp is going to function normally, right? It will shine brightly, and it will, so let me write here, lamp. So the lamp will function normally, right? Now, let's take again. So here the lamp will function normally. Let's take again the same circuit. But what I'm gonna do is I'm going to open up, like make a cut here in this wire. I'm gonna open up the wire. Will the lamp shine? Well, of course it won't, because there is no current there's no current passing through the wire, because it's an open circuit. So we call this an open circuit when the circuit is not closed, and the wire won't be able to conduct the current. So this is an open circuit. The lamp here will function normally, so it's a closed circuit. There's a third type of circuits. This type of circuits is the type that may cause the fire. Let's say we did a wrong connection and we added a wire here. Okay, so we added a wire here. Let us study how the current is going to move. So the current starts here. Now the current will take the path that is easier for her. Here we only have a wire, whereas here we have a lamp. What's easier for the current? Is it easier for it to make this lamp just shine, or it's easier for it to just pass through a wire? Of course, passing through a wire is way easier than passing through this. We call this easy, like when it's easier for the current, we call it that we have low resistance. Okay, so the resistance here for the current is way less than the resistance here. The resistance of the wire is way less than the resistance of this lamp. So what will happen is that the current will choose to pass through this wire here. Okay, and a very small current or a negligible current will pass here. Okay, what will happen is that since a big part of the current is passing through this wire's temperature is gonna increase, and this, as the temperature of the wire increases, this wire might burn out and a fire might occur. Okay, so we say that excessive current passing through a wire causes the increase in temperature of the wire and may lead to fire. So these fires that happen due to short circuit, well, in your everyday language you hear the word mass, right? There was mass in this kind of circuit. This mass, I guess it's a French word. this mass is what means short circuit, okay? So when a short circuit occurs, this wire is gonna increase in temperature and this may lead to a fire, okay? So let me review again what happened. We said that using the voltage of the main may cause some dangers, is risky, and there's the risk of electrocution, and there's the risk of fire. We just talked about the effects of electricity on the body and how dangerous it is, and how the current is what causes this danger. The danger is present more in the current, and we talked here about the duration that the body can withstand for different values of current. And then we talked about how fire occurs in a circuit. It's either due to the current overload or the circuit overload, because this appliance only can withstand a specific amount of voltage current, and it's given way higher than what it can withstand. And we talked about the short circuit, which is an error or like a mistake in a circuit where making the current pass through a wire, and the wire can't withstand this amount of current, making the wire temperature increase, and finally what will happen is that this wire might burn out, okay? Now, in the next video, we are going to talk about the protection, okay? What we use, what are the means to protect from electrocution and from burning out or the fire that might take place due to a sudden increase in the current. Okay, now wait for the second video, and for now just copy the notes that are found in the video. I'm going to send you a PDF with all the notes, and